For question number 7, the equation that is given to you is a trigonometric equation sin theta plus cos theta whole square, which is equals to 1, and the range over here that's given to you, it's basically that's domain. Theta is between 0 to pi. So finding the solution of this equation by making a restriction over the range 0 to pi, you have to find the remaining answers or remaining values for that. Very easy, that's not a problem. This is cos square plus sine square whole square. You can open this formula by using a plus b whole square method again. In this paper, mostly all the questions are using the formula a minus b whole square or a plus b whole square, basically from the trigonometric equation. You can see from the circle and from the graphing, all these questions are using this formula again and again, again and again. Anyways, this formula can be opened as cos square theta plus sine square theta plus 2 times sine theta cos theta, which is equals to 1. I can make a group of this thing because I know that sine square theta plus cos square theta is equals to 1. So it can be written over here 1 plus 2 sine theta cos of theta, which is equals to 1. It can be written over here 2 sine theta cos theta, which is equals to 1 minus 1. Cancel each other, which is equals to 0. Now I have sine theta cos theta, which is equals to 0 by 2, that is again 0. So here are two variables, sine theta and cos theta, which is equals to 0. If you remember, in the paper for February-March 2023, I was explaining a point. If two variables product are seems to be 0 and you don't know which one is 0, so here you have to construct two cases. Case number 1 was putting x is equals to 0 and y is not equals to 0. So putting x is equals to 0 will give you some values. And case number 2 defines y is equals to 0 and x is not equals to 0, and from that you have some values. So whenever you have a product of some variables and both the terms are variable, that's the condition. So if both the terms are variable and their product are 0, you have to construct cases over here to check which one is actually 0 and what happens when you put other one as non-zero. That's all about that we did in the one of the question for February-March 2023. So I have to construct two cases again here. So my case number 1 gives me sine theta is equals to 0. So when sine theta is equals to 0, then my theta would be sine inverse of 0. And I know that sine is giving me 0 only whenever my theta is 0 or my theta is pi. Second case is when cos theta, which is equals to 0. So theta would be cos inverse of 0. And you know that cos is only 0 whenever your theta is 90. That can be written as pi by 2. Now look at the conditions that are fulfilling here or not. Your theta should lie between pi and 0. So this pi by 2 is lying between 0 to pi because this is your 0. This is pi by 2, this is pi, this is 2 pi by 3, and this is again 2 pi. So this pi by 2 is basically lying over here, like for that. So for cos, it is under the range, no issue. For sine, 0, 0 is lying over here at the top corner, that is included in the boundary, you can say. So 0 is fine. Pi, pi is also like theta is between 0 to pi and there is equality. So pi can also be taken, no issue. Both the values for sine is also lying in the range. So as a whole you have 4 answers or 3 answers, you can say 0, pi and pi by 2. That's all about that. For the next one, Hence, verify that the only solution of this equation between 0 to pi are 0 and pi by 2. Alright. Now here you have to show that the only solutions are 0 and pi by 2. Why? Authors say that show that pi is not a solution. How I can say pi is not a solution? I have to put in the equation and check either that is making right hand side is equals to left hand side, then I am able to find that. Otherwise I am not. So the procedure to prove this situation is that putting theta is equals to pi in this equation in cos of theta plus sine of theta which is equals to 1, and check either right hand side is coming as left hand side. If it's coming, then okay. If it's not coming, then it's our required result is proved that that is not a solution. You know that a value will be a solution of some equation if it seems to left hand side is equals to right hand side. If it's not showing, it means that the solution is the value that is found by you is not a solution of that equation, because it's not going to satisfy the equation actually. That was a simple method to show whenever some value is a solution of some equation or not, and all these things. So put theta is equals to pi in this equation and check what happens. That gives cos of pi plus sine of pi which is equals to 1. Cos pi gives to minus 1. You know that cos of 180 is minus 1. Plus sine of pi is always 0 which is equals to 1. Now check minus 1 is equals to 1. Clearly it's not. Minus 1 is never be equals to 1. It means that left hand side is not equal to right hand side. So it's proved that theta is equals to pi is not a solution of this equation. That's all about this part. For the next one B, you have to show the trigonometric equation. Very easy, not a big issue. Trigonometric identity can be proven by considering the one side and showing that this is equals to another side. So I just like to consider this side. After considering this side, that gives me sine of theta by cos theta plus sine theta plus 1 minus cos of theta dividing by cos of theta minus sine of theta. I can take the LCM. Cos theta minus sine theta and cos theta plus sine theta can be taken as an LCM. So after taking it LCM, my numerator would be sine of theta times by cos of theta minus sine of theta plus 1 minus cos theta is an integral multiple of cos of theta plus sine of theta. Not a big issue. Simple LCM property. Now multiply the terms inside. I have to move it down to make it more space. Come on. Now multiply the terms inside and do simplification. Sine theta cos theta will be sine of theta times by cos of theta minus sine square theta plus 1 is multiplying inside and giving me cos of theta plus sine of theta minus cos is multiplying over here giving me minus cos square theta minus sine theta and cos theta whole divided by cos theta minus sine theta and times by cos theta plus sine of theta. Now sine theta cos theta at the first term and sine theta cos theta as the last term can be cancelled. Yeah, it can be cancelled. And the remaining terms would be cos of theta plus sine of theta minus sine square theta plus cos square theta whole dividing by, this is actually a plus b, and this is actually times by a minus b. You know that a plus b times by a minus b can be written as a square minus b square. So it can be written as cos square theta minus sine square theta. So further, it is cos theta plus sine theta, take minus inside common, and that gives you, this is actually minus, sorry, my bad, this is minus. You can see over here, yeah, this is minus, this is minus, a writing mistake, minus. Minus can be taken as outside and giving me sine square theta plus cos square theta whole dividing by minus sine square theta plus cos square theta. That is a trigonometric equation which is equals to 1. So it can be written over here, cos theta plus sine theta minus 1 whole dividing by cos square theta minus sine square theta. Right? Now you have to use one more trigonometric equation over here in order to show your answer. This is cos theta plus sine theta minus 1. You know that cos square theta plus sine square theta which is equals to 1. Am I right? Now write cos square theta is equals to 1 minus sine square theta. You can write. So cos square theta can be written as 1 minus sine square theta minus sine square theta is as it is because of this one. I just put the value of cos square theta from a trigonometric equation, nothing else. So after doing this, I can do cos theta plus sine theta plus 1, which is dividing by 1 minus 2 sine square theta. That is a required result. And that is the required right hand side of this equation. So I have proved this one, that these sides are equals. So I can say right hand side is equals to left hand side. Not a big issue. So that's all about that.